Let's look at another type of trig substitution. This time the format's going to be reversed from the first video. Under your radical term, if you happen to see the order of x squared minus your constant squared, then we're going to use the substitution a secant theta for our x variable. Once we've made that replacement, then we're going to also remember the Pythagorean identity secant squared theta equals 1 plus tangent squared theta. So let's jump into an example. This example, where we're going to use a secant substitution, note the radical term x squared minus 16. The square root of 16, and it's just coincidence that it was 16 in the first video too, but its square root is 4. So we're going to make the substitution x equals 4 secant theta. The derivative of x, which will give us our dx substitution, is 4 secant theta tangent theta d theta. Going back to the original problem, x cubed will be 4 secant theta quantity cubed square root radical we can write as a power of 1/2. I think I'm going to leave it in radical form for a step or two. Okay, so x squared, that's 4 secant theta quantity squared minus 16. And then dx, we have it right above in our derivative line. Okay, so everything has a substitution. Under the radical, 4 secant theta quantity squared, that can be written as 16 secant squared theta. The first term, 4 secant theta quantity cubed, is 64 secant cubed theta. Okay. Under the square root, like we did in the first video, in your mind, let's factor out a 16. That will leave 16 parentheses secant squared theta minus 1. A few other things along the way. While we do that, in the parentheses at the end of this line on the third row, 4 secant theta tangent theta, I'm going to go ahead and multiply that with the first term, which is 64 secant cubed theta. Getting that together, 64 times 4. Secant cubed times the secant in the back makes secant to the 4th. Tangent theta. Now under the radical, we can take care of that. 16 secant squared theta minus 1 d theta. Again, be super careful along the way that you don't introduce new stuff, but you don't leave any of the terms out either. So I'm going to pause just for a second, let you look at that third row, make sure everything was kept going into that last row. Okay, on the next slide, we're going to change secant squared theta minus 1 to tangent squared theta and make that simplification. It's just important to balance out progress versus error. The square root term will become 4, I forgot my square, 4 tangent theta. Okay, so when that becomes 4 tangent theta, multiplying it into the 3 terms in front of it, we get 1024 times secant to the 4th power theta, tangent squared theta, d theta. And I'm purposefully going slow because it takes a little bit to mentally make sure that you haven't left anything out. I think we're good so far. I'm going to factor out the 1024. I'm going to also split secant to the 4th power up into a couple of secant squareds. From here, I'm going to change the first secant squared theta to 1 plus tangent squared theta. That's a Pythagorean identity. The direction I'm going to take this is I'm going to try to get everything in terms of tangent because its derivative is secant squared, and I've got that written out back in kind of in a holding pattern. Old champ's either got to be eating, drinking, or barking during a video. Never fails. Distribute tangent squared through the parentheses. I'm going to move to another slide and I'll do that. Okay, distributing tangent squared. Okay, I'm going to let u be tangent theta. Du is secant squared theta d theta, which is the very end of the step above. And that's why we did some substitution methods in the beginning videos of the class, is to prepare us for this moment. Okay, so take a minute, look at the top row. If u is equal to tangent, that gives us u squared plus u to the 4th. Secant squared theta d theta, we can rewrite that with a du. Now it's time for the antiderivatives. Add 1 to the power, divide by the result. Plus C. Now this one's got a lot to keep up with because in the beginning we traded out X for a trig function. Then we traded out a trig function for the letter U. So now we got to unwind it a couple of stages. We've got it back in terms of U, and the integral, the antiderivative part, is complete. So let's change U back to tangent, and then we'll use a triangle in the original substitution to go back to X. That's the game plan anyway. Let's give it a shot. Okay, we had 1/3 U cubed, but U was tangent. Plus 1/5 U to the 5th. But that's going to be U traded out for tangent again. Tangent to the 5th. Okay, so now we're back in our trig terms instead of U. That's unfolding at once at least. Let's remember the very original substitution was 4 secant theta. So x over 4 is equal to secant theta. Secant is hypotenuse over adjacent. Think of it as the opposite or reciprocal of cosine. Cosine's adjacent over hypotenuse, so the reciprocal of that was hypotenuse over adjacent. And once you know 2 of the 3 sides of a right triangle, Pythagorean theorem will give you the third. So the leg on the left side is going to be the square root of x squared minus 4 squared, which is 16. Going back to the top row, we're going to replace all the tangents with the x terms from this right triangle. Tangent is opposite over adjacent, so each of those tangents we're going to replace with square root of x squared minus 16 over 4. Now for my class, you'll be typing your answers into WebAssign, and WebAssign is very forgiving on what you type in. On the next slide, I'm going to show you what a little bit simpler of an answer would be. This step is actually fine for WebAssign. It's very tempting, like in the first part of those brackets, that 1/3 and then that 4 in the bottom, to call that 1/12, but that power 3 means that there's 4 3's in the denominator. So it just kind of gets hairy from here into the simplification. You're more than welcome to simplify, but WebAssign is very good at taking a pretty complex answer that's correct, and it doesn't demand a very simplified answer. But if we do it, this is what it should look like. Okay, so we had square root of x squared minus 16 over 4 quantity cubed. If I put the third with the numerator and denominator separately, the 4 on bottom cubed becomes 64. And then we had 1/5. Same fraction all to the 5th power. If we apply the 5 to the numerator and denominator separately, we can have a similar breakdown. Four to the 5th, I believe that's a 1024. Yeah, it is. Okay, on the numerator, a square root raised to the 3rd power can be written as a solid power of 3 halves. Three times 64, that's 192. Square root of x squared minus 16 to the 5th. That can be written as a power of 5 halves. Five times 1024. 5120. Distributing the 1024 and simplifying the fraction, we will get 16 thirds. That'll be 1024 over 192 reduced. A 1024 over 5120 reduced. Will give us 1/5. And this would be a simpler answer that's equally as correct as the end of the slide right before this one. So you guys be your own judge on how far you want to simplify versus risking the error. Again, for my class, I use WebAssign from Cengage that will take a fairly non-simplified answer, and as long as it is technically correct, it'll accept that answer.